Okay, so today we're going to talk about a permutation. Once again, n factorial is the product of all the integers from n down to 1. So when we evaluate the factorial, for example, n factorial, or in this case, 5 factorial is going to be 5, 4, 3, 2, 1. 0 factorial is going to be 1. A permutation is pretty much an arrangement of objects, or an ordering. My favorite is to think about it as a label. If you're applying a label to something, you're going to have a permutation. There are 3 types of permutations that we have. We have a general permutation, where it's just going to be n factorial. We have a permutation of R objects, where you're only arranging R objects out of the n total objects. And we usually denote it as n permute R, and that is represented by n factorial over n minus R factorial. We also have a permutation with repetition, where you're repeating a certain object over and over and over again. So if we were to evaluate, for example, 7 permute 4, this would equal to 7 factorial over 7 minus 4 factorial, which in this case is going to be 7 factorial over 3 factorial, which is 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. And this kind of reminds you of your fundamental counting principle, where you have 7 objects but you only have 4 spaces. So if I have 7 objects and I only have 4 spaces, the first place can be, or the first space, you have 7 options. Once you put an object there, then for the second space you now have 6 options. For the third space you have 5, and for the fourth space you have 4. So it's very similar to the fundamental counting principle. But in this case, we're giving it a label. The first space, the second space, the third space. So in this case, this entire thing equals to 840. Okay. When we have 10 permute 0, this would mean 10 factorial over 10 minus 0 factorial, which is another 10 factorial, which is 1. So the number of ways that you can order 0 objects out of the 10 is 1 way, if you just don't do it at all. Once again, if you have 10 objects and you're trying to arrange 0 of them, there is 1 way to do that, which is not doing it. In your calculator, you have these numbers, you have these computations are going to be in your math button. So I can go to math, and we are in probability, so then I would just go all the way to probability, and then you would press 2. So first you would need to enter like the total number of objects. So if I want to do 10 permute 0, I would have to do 10, and then math, go to probability, and then number 2. 10 permute 0. And you can see that that is also 1. Okay. So now let's go ahead and apply it. So you have 5 homework assignments for 5 different classes this weekend. Part A. In how many different ways can you complete all of the assignments? So this is more or less like a fundamental counting principle. I have 5 assignments for this weekend, so it's like having 5 different slots. 1, 2, 3, 4, 5. For my first assignment, I have 5 options. For my second assignment, since I already did 1 of them, now I have 4 options. For the third assignment, I've already done 2 of them, so I have 3, and then 2, and then 1. Or in another way, this would be 5 factorial. This is kind of like our general permutation, where you're just arranging all the objects. So in this case, there are 120 ways in which you can do that homework, or in which you can complete all of the assignments. Part B. In how many different ways can you choose 2 assignments to complete first and last? So in this case, we're no longer arranging all of them, we're only arranging 2 of them. But more importantly, we're applying a label, first and last. And whenever you have a label, you're going to be having a permutation. So in this case, I'm looking at how many options do I have for the first, and how many options I have for the last. So in this case, it would be 5 for the first, and 4 for the last. Or another, which is actually 20 ways for me to complete this assignment. But remember that another way for me to think about this would be to do 5 factorial, or 5 permute 2, which is 5 factorial over 3 factorial, which still gives you this. Alright, backside. There are 30 contestants in a writing contest. If first, second, and third place are to be chosen, in how many ways can the 3 winning positions be selected? So you have 30 contestants. You're only going to be arranging or labeling 3 of them. And because we have a first, second, and third place, you are now in a permutation because you are labeling. You are arranging. So anytime we have a label, an arrangement, or an order, you're going to be a permutation. To me, it's easiest to think about it as a label. So in this case, I'm labeling first, second, and third. So out of the 30, I'm going to permute 3 of them. So by definition, this would be 30 factorial over 30 minus 3 factorial, which is 27 factorial, which is the same thing as 30 times 29 times 28 times 27 factorial over 27 factorial. This ends up being 24,360. Once again, you can complete this entire thing in your calculator, but it's always good to know how to do it by hand. Another way to do this, once again, is you have a first, second, and third place. So you can always just think about it as first, second, and third. Out of the 30 contestants, there are 30 possibilities for somebody to get first place. Once somebody gets first place, then there are 29 possibilities for somebody to get second place. And then there's going to be 28 possibilities for somebody to get third place. So which is this right here. Alright, so that is whenever we're arranging or labeling some objects, not all of them. Example 4. In how many ways can you arrange the letters in the word math? So in this case, we're looking at an arrangement. So we're assuming that every word that you come up with is going to be a word, regardless of whether you have too many consonants together. So in this case, I have 1, 2, 3, 4. 4 factorial. There are 4 factorial ways, which is 24 different words that I can come up with. I could think of this as having 4 slots, because if I'm going to use all the letters, then I have 1, 2, 3, 4. And then for the first letter, well, I have 4 options to choose from. Once I use a letter, then I'm going to have 3 options, and 2, then 1. Alright. The next one is a little bit trickier, because you have A's being repeated. It's like having, for example, let me do it off to the side. You don't have to write this down on your notes. But if I have the example based on what I just said, then there should be 3 factorial ways, which would be 6 ways for me to make up letters with those 3, make up words, 6 possible words with those 3 letters. But that would be considering the example where I can have E, E, Y, and then switching these E's, E, E, Y, and then E, Y, E, Y, E, E, and then switching these letters, Y, E, E, and what else am I missing? Oh, and then switching those at the beginning, E, Y, E. But you'll realize that switching the E's at the end doesn't really create another new word, and in fact, you're actually double counting words just because you switch the E's. So in this case, because we're double counting, we have to get rid of that. So first, we count how many total letters there are. So in this case, there's 1, 2, 3, 4, 5, 6, 7. There are 7 of them. So usually my answer would be, oh, there are 7 factorial ways for me to make new words. However, there are 2 that are repeated, the A's. So I'm going to say there are 2 A's. So because I'm repeating all the possibilities where I'm switching those around, I'm going to divide it by 2 factorial. And that's going to divide out all the possibilities divided out by the ones that you double counted. Or in this case, if I already have E, E, Y, and I switch these E's, I'm double counting it, so I'm going to divide by him. I'm going to divide in the end by 2 factorial, because there's 2 E's. And dividing by 2 factorial is going to give you 6 divided by 2, which is 3, which pretty much gets rid of the double counting. So that's what we're doing. In this case, the algebra problem, the answer would be 2520. The Mississippi problem. Once again, we count how many total there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we go ahead and divide out all the repeated factorial. So in this case, I start with M. There's only one M. But then I go on to I. And I realize that there's 1, 2, 3, 4 I's. you'll notice that my pattern is usually to put a dot to count them, and then I go in order and I cross them out so that I know that I've already gotten rid of them. The next letter would be S, and there are 1, 2, 3, 4 S's. And the last one would be P. There are 2 P's. So, in this case, there are 11 factorial ways, but if you just do 11 factorial, you're double counting. So I'm going to go ahead and divide out by all the letters that were repeated, and that will not make any new word just by moving it around. So 4 factorial for I, 4 factorial for S, and 2 factorial for P. And this will eventually give you 34,650. Alright, so now we move on to how many ways can 3 apples, 2 oranges, 4 pears, and 1 banana be given to 10 children if each child receives a piece of fruit? Well, you'll notice that 3 apples, we're assuming that they're just apples. So apples, apples, apples. Orange, orange. Pear, pear, pear. They're not really different. So in this case, I like to denote this as apple, apple, apple. Orange, orange. Pear, pear, 4 pears. So 1, 2, 3, 4. And 1 banana. So now it just looks like our example from above. In this case, the number of ways that I can arrange these or give these out would be, well, how many there are total, which in this case there's 3, 5, 10. Or you can just count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I can divide out all the repetition. If another kid gets an apple and I get an apple, then it's the same as if he got my apple and I got his apple. So we don't want to double count. In this case, there are 3 A's, there are 2 O's, there are 4 P's. So the number of ways that I can distribute all of these apples, oranges, pears, and bananas, given that all the apples are the same, all the oranges are the same, and all the pears are the same, would be 10 factorial over 3 factorial, 2 factorial, 4 factorial, which ends up being 12,600. I suggest that you try this in your calculator, that you know how to enter this in your calculator, especially if you have an older graphing calculator. Alright, last example. In how many ways can the letters of the word Tuesday be arranged using only 4 letters at a time? Well, you'll notice that none of the words are actually repeated, but this is no longer the previous example because I'm not actually arranging all the letters. If I was arranging in how many ways I can create letters using all the letters in Tuesday, then it would just be 1, 2, 3, 4, 5, 6, 7 factorial. But because I'm only using 4 letters at a time, then this is 7, and I'm choosing to arrange only 4 of them at a time, which is 7 factorial over 7 minus 4, which is 3 factorial. This ends up being 7 times 6 times 5 times 4 times 3 factorial over 3 factorial. And once again, this is the same idea as if I had only 4 slots, or creating 4-letter words, where I have 1, 2, 3, 4 slots. For the first letter, I have 7 options. Once I use it, for the next one I have 6, for the next one I have 5, for the next one I have 4, and that's it, because I'm not planning to use all the letters in the word Tuesday. Together, all of these multiply to 840. Okay, make sure that you copy these down and you try with a calculator, and good luck.